class. For this Excel instructional video, I will show you how to create a scatter plot, calculate the correlation coefficient, and create a linear regression model. For the video, I will be using Excel 2016 for Mac. So here we go. We've got, in our first page, we have some data already entered in. The data is for fat and sodium content from several hamburgers at fast food restaurants. You might recognize this data from the presentations where you learned the information about linear regression. Okay, so the first thing that we're going to do is we're going to create a scatter plot of this data. The easiest way to do that is to select your data and go to Insert. And here you'll see a lot of chart options here. We want the scatter plot chart option. So when we click here, we're going to see scatter. And you'll see it just pops right up. Okay, so that's pretty easy. We just want to make sure that our chart is showing us everything that we need, and I've noticed that we don't have any axes labeled. So not labeling axes means that you don't know exactly what information you're transmitting. So we need to make sure our axes are labeled, and for any paper that you write or any assignment that you do, those need to be labeled in order to gain full points. There's an easy way to do that here. If we go up to Add Chart Element, we see axis titles. We need to label both of them. So our primary horizontal axis is fat. And in this case, this is called the explanatory variable, right? So this is the variable that we are using to try to explain sodium content. I'm not so sure that that's really necessarily the case in here, that fat explains the sodium content or that sodium would explain fat content. But in this case, we just made a decision to make fat our x, our explanatory variable, and sodium our y, our response variable. In this case, we probably could switch them around and just as easily do our analysis. But when you're choosing your explanatory versus your response variable, often that comes from the hypothesis that you've written. Okay, so we have our x-axis, our explanatory variable, and now we want to do our vertical axis, and that title is sodium. And notice that for both of these, I've put the units of measurement. That's important to include as well. And automatically, Excel put in sodium, our response variable, as our title. We probably want to title it something different. Perhaps, I don't know, fat versus sodium in fast food hamburgers. Okay, and so that should do it for creating a scatter plot. So we're going to move on to how you calculate the correlation coefficient and how you create a linear regression model. But we're going to do that on a separate page to keep things neat. Okay, so you'll see the exact same set of data. And for these operations, we're going to use the analysis tool pack. So we need to make sure that that is turned on our Excel. So the way to do that is to go up to Tools and cruise down to Add-ins. And here you'll see Analysis Tool Pack. I already have mine turned on, but if yours is not highlighted, you're going to need to click it. If you're using Excel 2016, which I highly recommend, you will automatically have the Analysis Tool Pack. If you're using an earlier version of Excel, this may not be available, and we will need to find another way for you to do your analysis. So I'll say OK. Now, to access the Analysis Tool Pack, we go to Data, Data Analysis, and you'll see a whole list of options for analyzing data. But what we want to do is regression. So I'm going to say OK. It's going to ask me some questions. It's going to ask for my input y range. So remember, we're going to say that sodium, our y, is our response variable in this case. So it actually automatically has it in there for me, but you may need to choose it. If you need to choose it, click on this arrow and go over here and just highlight that column. And click on the arrow again, and you'll see it's there. Input x range, same thing. I have my a's already there, my explanatory variable, but if I needed to highlight it, I would just click on the arrow, highlight it, click on the arrow again. I do have labels in my first row. My first row right here is labeled fat and sodium, so I need to tell it that. That'll help me. And our output range, I'm going to tell it where to put the information. I'll have it put it in this cell. You can choose wherever you want. I like to put it in the same worksheet as opposed to have it set up a whole new worksheet. I find that to get too many and too confusing. So I think this is the best option. And I'm going to have it also create a line fit plot. Okay, so we should be all set here, and I'm going to press OK. Wow, so we see a lot of information show up here. So let's figure out how to wade through this information. I'm going to ask you to do something very similar on a homework assignment. So why don't we begin with our graph? You should see, I'll make it a little bit bigger just by dragging the corner. You should find that it looks very similar to the graph that we created before. Okay, so, but you'll notice that we have, in addition to the blue points that we had before, we have these red points. So the blue points are our actual data values, and you can see exactly what the value is just by hovering over it. Okay, it'll tell you that this one is 35 for fat and 860 for sodium. Okay, so so that's the blue points. The red points are my predicted values. They're the points that make up my trend line. So I actually want my graph to show the trend line. So what I'm going to do is I'm going to click on one of these red points, and it'll highlight all of them. Then I'm going to right click. And here it says add trend line. I want that on there. Gives me some options. I definitely want linear because that's all we're learning in this course. And I might ask it to forecast a little bit backwards and forwards. We call that extrapolation. So maybe I'll have it go forward a little bit past the last value, which was 43. I don't know, I'll set this maybe at 50. And maybe I'll have it go backwards to, I don't know, we'll say 15. Okay, and then otherwise everything is all set. And you can see that our trend line has been created. Okay, and you also will notice that our axes are already labeled for us. And that's because we had that option of setting the first row as our labels. So it already knew that. The only thing that we might want to do is change our title. We can do that just by clicking on it. Okay, and we can just say fat in grams versus sodium in milligrams for fast food hamburgers. Okay, so there you have that. So we've got our trend line, we've got our scatter plot. Okay, so you see all this output that we got when all we were trying to find was our correlation coefficient and our equation for our regression line. So we've got to kind of figure out what all of this stuff is. So I'm going to ask you to do this on a homework assignment later, so watch carefully. Here, I'm going to highlight what the correlation coefficient is. Okay, I'm just going to highlight it in yellow. That value where it says multiple R, that is your correlation coefficient. Okay, so when I ask you for that, you're going to report your correlation coefficient as 0.199. So you might notice that's really, really small. There is not a very strong linear relationship between these two variables, and I can see that here when I look at my scatter plot. If I was to describe my scatter plot, I would describe it as pretty weak, maybe positive. Well, I don't know, I guess I could guess it's approximately linear. It doesn't really have a specific shape. Okay, so there's my correlation coefficient. The other information I need to create my equation of my line for my regression line are the slope and the y-intercept. And you're going to find those right down here. So I'm going to highlight this whole section. Okay, and I see that where it says intercept, my intercept is 930. And I can see that next to fat, it's 6.08. So what that means is my y-intercept is 930.016, and my slope, the other value is my slope, is 6.08. Okay, so that's all the information that you need in order to calculate the correlation coefficient and find the equation of the regression line.